Hey everybody, this is Mr. Lowry, and this worksheet is your volume of cylinders and cones worksheet from day 1 for the week of March 1st. So this would be from Monday, March 1st for A day, B day. This would be Tuesday, March 2nd. We have two three-dimensional shapes that we're talking about today. They're cylinders and cones, and we're finding the volume of those guys. And volume is a three-dimensional measurement that could be like how much like water or air or something that you can fit inside one of these three-dimensional objects. Okay, so let's start with the cylinder, and I'll give you the volume formula. Okay, the volume formula for a cylinder is pi r squared h, where r represents the radius of the circular base and h represents the height of the cylinder. Okay, now a couple notes on a cylinder. Okay, let me give you an example. Okay, this is a cylinder. On a cylinder, the base is the circular part. So notice there's a circle here, and then you have kind of this like tube. So regardless of whether the cylinder is sitting on its side like this or whether it's sitting like this, and kind of go up a little bit. The base is always the circle part. Okay, the height is always measured perpendicularly to the base. So if you're looking at the cylinder like this, you get the circular base, and this is the height, which kind of makes sense. If you're looking at it like this is still the base, even though it's not on the bottom, and this is the height, even though it's not going up and down. Okay, so the base is always the circular part. The height is always measured perpendicular to that. If you look at the volume formula, you'll notice that inside the formula itself, let me go back down here, you'll see a circle formula. So pi r squared right here is the area of the circle. And we multiply that by the height. So what you're doing basically is you're taking a bottom circle, right, two-dimensional area, and then all of a sudden you're multiplying that up in a direction here until you get a three-dimensional shape. So that's kind of what that formula means. Find the area of a circle and multiply it by this third dimension so that you have this three-dimensional volume inside. How much space fits inside this three-dimensional object. Okay, so let's take a look at a couple of these. Now notice some of them are on their side, and that's okay. Let's take a look at one of the ones on their side. When you look at, like, let's say number 4, they're showing this guy. So the circle is the base. I know that's kind of weird, even though it's not on the bottom, right? So that guy's called the base of the cylinder, and we want to find the radius of it. Now this is the diameter, so the radius is pretty easy to come by. It's just half of that. So volume equals pi r squared h. Okay, we know the radius is going to be equal to 6, half of that diameter, and the height is equal to 5. I know, again, it's weird to say that this is the height, but remember the height is always measured perpendicular to the bottom, to the base. Okay, so there's your height. We're just going to throw these in the formula. Now it asks you to find an exact answer and a decimal approximation. So when we use pi, which is an irrational number, we're going to get irrational numbers, and we want to be able to work with those. So the volume is equal to pi times r squared, which in this case would be 6 squared, times height, which is 5. Okay, so we got pi times 36 times 5. So that's going to be, I think that's 180, if I'm not mistaken. Let me double check really quick. 36 times 5. Yep, 180. Okay, so the volume as an exact number is 180 pi, and my units is yards cubed. Okay, or cubic yards is another way to put that. So basically, how many cubes fit inside this guy? Okay, 180 pi of them, cubic yards. So here's our exact answer. Okay, we also want to do that as a decimal approximation. So if we take that and we multiply by pi, we're going to get something like this. 565.49, again, cubic yards. Okay, so I think I said round to the nearest, I said round to the nearest tenth, sorry. So this would be 0.5. Okay, cool, so we have both of them. So that's how you do a cylinder, okay? Now some of these guys are a little bit trickier if you move over to like the second side, because not everything that you need is given to you. Okay, so here's 4 that are gonna be a little bit trickier, and I'll kind of do a couple of these with you. So on a few of these, what they're giving you is like a diagonal length across the cylinder, but notice that we have this this right triangle basically sitting inside here. Right, so what I want to do here is I want to find the height, which is this guy, and I can use this idea that this is a right triangle to get there. When you organize your problem, this is how I recommend that you organize it. Okay, start with the original problem. You want to find volume, pi r squared h, right out of the formula. Then start listing all the stuff that you know. Okay, so for example, I need r. Okay, and so what I did is I indented a little bit. This is the problem, but I have a sub-problem. So I'm coming in here and I'm finding the radius. Okay, notice this is not the radius, it's the diameter, but I can get to the radius pretty easily by dividing by 2. Okay, so the radius is 4. The next thing I need is height. Okay, so again, this is not part of the problem, the original problem, this is like a sub-problem, and that's why I've indented here. These problems here are multiple steps, and if you mess up any of the steps, the whole problem is going to be wrong. So organization here is key. This is a common problem-solving strategy, is just to figure out what you know, what you don't know, and then kind of do it in a step-by-step systematic process. In this case here, I need h, and h stands for the height of the cylinder, but notice I have a right triangle. So this dotted line here is 17. Right, again, that same thing here. This is 15. So they're giving you these diagonal measurements, and you're trying to find, missing pieces here. So, yeah, here we go. H is going to be 8 squared plus h squared is going to equal 17 squared. So we need to use our Pythagorean theorem here, and we're going to solve for h. So we got 64 plus h squared equals whatever 17 squared is. I'm not sure what that is, so let me find that really quick. Okay, that looks like that's going to be 289. And then we need to solve for h. Okay, again, let's keep it organized so that you don't make any mistakes. A lot of students will try to kind of rush through these, and then they'll miss one little piece, and then everything will be off. Okay, so h squared equals 225. I don't want h squared, I want just h. So I'm going to take the square root of both sides. So let's do that really quick. And that's going to give me h equals 15. So that comes out kind of nice. All right, so now I have h, but again, that wasn't my problem. So what I can do is I said, okay, I need the volume here. I need radius and height to do that. I've now got both. Now I can actually come out here and finish my volume problem. So pi times radius squared, which would be 4 squared, times 15. Okay, so my volume here is going to be 16 times 15. Okay, so that's going to be 240 pi, and this is inches cubed. That's my exact answer. Did I say, see, find the measurement, show your work in order steps, round your answers to the nearest hundredth. Okay, so that's my exact. Let's turn that into a decimal approximation. Okay, so that looks like it's 753 point nearest hundredth, 98. Cubic inches. All right, now this next one's kind of interesting. It's not a full cylinder, and you might be kind of like freaking out on this one, but if you take a second to just remember what we know about sector area, this is actually not too bad. So what we got here is we got this full, I don't know, it's part of a circle, right? It's a piece of a cylinder. So what we can do is we can take this piece, right, we can find the area of this kind of Pac-Man looking thing, and then multiply it by its height, and then we'll get the volume. Okay, going back to what we knew about sector area, the sector area is a portion of the full circle. Okay, so although this isn't a cylinder, hopefully at this point you can kind of combine some ideas to understand what's going on here. Now, if this angle is 120 degrees, it's kind of hard to see that because of the angle here. This doesn't look like 120 degrees, but you know, if you were looking at the circle from the top, it might be a little more obvious. That's the section that's missing. Okay, so we want the rest of it. Okay, so first of all, we need to find the area of the sector, right? The area of that piece. And if I redraw it here, it looks something like this. Again, this is kind of hard to visualize. But this is 120 degrees, right? And then my radius is 4 feet. So if I want that sector area, I know that I need the rest of this. So if this piece is 120, then the rest of this is 240 because they have to add up to 360. So I have 240 degrees of the entire circle. Okay, and again, I got that by the full 360 minus 120 is 240, and again, the full circle is 360. So this is a portion of the circle. That's going to give me some ratio. I think that's actually 2/3. And then I'm going to multiply that by the circle area, which would be pi times 4 squared. Okay, so that's just the sector area. Let's see what that comes out to be. And I'm just going to double check that we actually do have 2/3 here. 240 over 360. Okay, that's true. So it's 2/3. That's this fraction. And then this is going to be 16 pi. Now, since 3 doesn't go into 16, we can't really simplify here, but we'll have 32 pi over 3. All right, that's the area of the sector, just this little piece, this little Pac-Man piece. Now we need to take that and we need to multiply across the height to get the full volume. So it's kind of using that cylinder idea, but instead of taking the whole circle times the height, we're taking a sector times the height. Okay, let's finish that up. So now we have the sector area. We're going to do sector area times height. Multiply it by that third dimension. We're taking a 2-dimensional area and multiplying it by a third dimension to get a 3-dimensional area. So 32 pi over 3 times 10 is going to be 320 pi over 3. So notice, again, I'm waiting until like the very, very end to simplify. And then we'll figure out what that is. So 320 times pi, and then divided by 3. So that looks like 335.1 cubic feet as my decimal approximation. Okay, a little tricky, but if you combine the idea of where the formula for a cylinder comes from with the idea that we already know about sector area, you can pretty much find that shape. All right, let's talk about cones now. We'll start with an easy one. Okay, it turns out that cones and cylinders are really closely related. The volume formula for a cone is 1/3 pi r squared h. And that looks really familiar because this guy, pi r squared h, is the cylinder volume. Okay, so a cone is 1/3 of the volume of a cylinder that has the same base and the same height. So if I were to like continue this, let's complete this cylinder. Let's say this cone is sitting inside of a cylinder, right? And this is the top, like that. The height of this cylinder is still 22 centimeters, the same as the height of the cone, okay? And the base is, we'd have to find the radius here, which would be 11, and then square it. So the area, the volume of this cone is 1/3 of the volume of the cylinder that has the same base and the same height. So that's not too hard, okay? Let's just put it all together. So volume equals 1/3 pi r squared h. Okay, I like to write that out every single time because it helps me to remember it. It also helps me remember what pieces I need. So I'm going to indent here, indent on the problem, and I'm going to solve for I'm going to find one of the pieces. I need r, so it's 22 over 2 because they're giving me a diameter here. So pay attention. Sometimes they give you a radius like this, for example. Sometimes they give you a diameter. Just got to pay close attention to what they're giving you. Okay, and the height is 22. Okay, we don't really have to do anything there. So let's put it all together. We got 1/3 times pi times 11 squared times 22. Now, we could try to simplify here, but 22 doesn't have any common factors with 3, and neither does 11 or the other 11, because this is 11 squared. So nothing's going to really happen there. I'm basically just going to figure out what 11 squared is and then multiply that by 22. Okay, so what we're going to get here is 2,662 pi over 3. That's my exact answer. Now let's include the units. This is cubic centimeters, right, or centimeters cubed. We're literally trying to find out how many little cubes fit inside that pyramid, excuse me, that cone. And that's our decimal approximation. We can multiply that number by pi and divide by 3. Do that really quick for you. Okay, so that looks like it's going to be about 2,787.6 if we're rounding to the nearest tenth. Okay, so we have both of those there. All right, let's do one that's a little bit more complex. Actually, we'll probably do 2 of these. Okay, so sometimes you're going to have to solve for missing things. You're going to have to do problems within problems. So we talked about how to use the Pythagorean theorem on some of these. We're also going to have to use special right triangles or maybe even some trig. So let's take a look at number 18 as an example. Okay, so this guy is 10. That's the height of my cone. Remember, it's measured perpendicular to the base. Okay, what I'm not given is r, the radius, but I am given this angle, which is 48 degrees. So let's start by writing out the formula. Again, this is a cone, so 1/3 pi r squared h. R, I don't know, but I do know height, so I'm going to start with height. Height is equal to 10. So again, I indented. I'm finding the pieces that I need to use the formula. Okay, let's talk about r. So what I have is a right triangle, and I have an angle. So if you remember, when we did trig, we had this thing called SOHCAHTOA. And SOHCAHTOA was a mnemonic for trig ratios and remembering trig ratios. So I'm going to write this out here and then talk about SOHCAHTOA. So we have 3 trig ratios. One's called sine, one's called cosine, and one's called tangent. That's what the S, the C, and the T stand for. O, H, and A stand for opposite, adjacent, and hypotenuse. So they tell you which trig ratio goes with which combination. So when I'm doing trig, I always start with my angle of reference, and then I label the triangle. So here's my reference angle. I draw a line through it, and that points to the opposite side. Okay. Here's the hypotenuse, because it's across from the right angle, and that makes this guy the adjacent side. So the 2 sides that I'm working with are this guy, the opposite side, and this guy, the adjacent side. So you're trying to find the ratio that you need that goes with opposite and adjacent, and that's tangent. Tangent is opposite over adjacent. Okay, so for the radius, again, this is just to get the radius. I have the tangent of 48 degrees equals the opposite side, which I know is 10, over the adjacent side, which I'm calling r, because that's the radius of the circle that I need. So we're just going to do some work in here. Tan 48 is not going to come out nice. It's going to be irrational. So we need to kind of solve for r first. So what I'm going to do is I'm going to multiply both sides by r, cancel it out here. That gives me r times the tangent of 48, which is just some number, equals 10. Okay, and I'm trying to get r by itself. So now I divide both sides by tan 48. Remember, that's just some irrational number. And then I get r is equal to 10 times the tangent of 48. Okay, now you can plug that into your calculator, but I might wait to do that until the end because we don't want to round yet. Okay, so this is my volume formula. Now what I did is I indented and I'm solving for all the pieces that I need. So now that we've got the height and the radius, I'm going to come back out and start solving the problem that I originally started with. So it's 1/3 times pi times the radius squared. Now the radius, again, is 10 tan 48. That's the whole radius. And then I multiply that by the height, which is 10. Okay, so in this case, it doesn't ask you to give an exact answer because I know when you're doing like trig stuff, like it's going to get pretty ugly. But my recommendation is just to wait until the very end of the problem to figure out what you get. So hold on to just a second. I'm going to grab a calculator. And let me show you how I would actually enter this. Okay, so as long as we use order of operations, we're like pretty much good here. So I'm going to do 1/3. Of course, this isn't the only way to do this, but it's one way to do it. And I'm going to multiply that times pi, and I'm going to multiply that times 10 times the tangent of 48 degrees. Okay, close the parentheses here, close the parentheses again. Okay, and then I'm going to square that, and then I'm going to multiply that by 10. Okay, so if you type that out correctly, you should come up with something like this. So let's see, round to the nearest hundredth, 6/8, and this is inches cubed. All right, now what I would do here is I would double check that answer because you just typed a bunch of stuff. So from here, I might go back and do it maybe one piece at a time and then just make sure I get the right answer. So let's kind of try that. So let's say I do tan 48. Okay, and then I multiply that by 10. That's the radius. And then I square that. Okay, so 123. And then I multiply that by 10. And then I multiply that by pi. And then I multiply that by 1/3 or divide by 3. Okay, so just double checking, right? Making sure that you got the right answer. You didn't make a calculator error. You didn't have an order of operations error. Because the last thing you want is to go through all this work and then at the end not get the right answer because you typed it in wrong. So double check, verify that you got the right thing. Okay, that's what we're after. All right, let's look at a couple more of these real quick. I'll help you set up a few of these. Okay, let's look at number 20. Now, in number 20, you could use the same idea. You could do trig here, absolutely. But what you might notice is that if this is 60 degrees and this is 90 degrees, then this has to be 30 degrees. And what you have is a 30, 60, 90 right triangle. So this side is 12, right? And if we recall the relationship between the sides of the 30, 60, 90, you'll remember that the short side we call x, and the hypotenuse is double that, and the long leg is √3 times that. And remember, square root of 3 is just some number, just some irrational number times x. Okay, so what I have here is I have the long side of this 30, 60, 90, and I want the radius, right? So what I can do is I can divide, like if I'm going here, right, from this side to this side, I need to divide by √3. So this side is 12 over √3. Now we might want to rationalize that, so 12 over √3 times √3 over √3 is going to be 12 √3 over 3, and then simplify the 12 over 3, that's going to be a 4 over 1. So this is 4 √3. Okay, so that's my radius. Now I kind of broke my own rule, which is kind of a no-no. I got excited to show you what was going on here, and I should have set this up a little bit better. So remember that we need two pieces of information for volume. We need radius and we need height. So what I should have done here probably is done volume equals 1/3 pi r squared h, and then started talking about the pieces, right? H we know is 12, and then R. And then I would have like kind of done this stuff, right? All kind of under the R category. Be like, okay, I'm finding R here, and I got R is 4 root 3. Okay, so that's probably how I should have structured it. But let's go back and finish it out. So volume is equal to 1/3 times pi times 4 root 3 squared times 12. Okay, now there's a bunch of simplification we can do, and this is good practice for your algebra skills and your simplifying skills. So let's do that first, and then we'll get the exact answer. So 1/3 times pi. Now think about this. If I square this, I'm going to have 4 root 3 times 4 root 3. Okay, so 4 times 4 is 16, right? So 4 squared is 16. Root 3 squared is just 3. Right? Root 3 times root 3 is just 3. And then I have a 12. This 3 is going to cancel with this 3, so that's nice. So I got 16 times 12 pi. Let's see what 16 times 12 equals. All right, so 192 pi millimeters cubed, or cubic millimeters. Okay, now if we want to turn that into an exact answer, we can do that. That's going to be 603.19 if we're rounding to the nearest hundredth. Okay, so keep it organized. Again, you don't have to do it this way, but I like to start with what I'm trying to find, and then indent and start talking about, you know, all the stuff I need, and then come back out. If you're a programmer, this is how you organize your programs. You're like, okay, function, I need this guy. Okay, subfunction, okay, I got to find these first. Then you return out from these two functions and then evaluate the original. So kind of a coding organization there. All right, now this guy, let me help you out here. We got this angle of the top of the cone is 36 degrees. But if you draw the height line, called the altitude, if you draw that down here, then really what you have is half of that, because this height line will bisect. So if you redraw your triangle, I don't know, it's going to look something like that. And this guy's 30, right? 30 or 30. I'm actually looking at this triangle. Sorry, I lost that. Let me get you up there. Okay, so here's the right angle. This guy's 30, the hypotenuse. And this guy now is 18 degrees. And we need to find the radius, right? And we need to find the height as well. So here's R, here's H, and we're going to need to use trig to do it. So original formula, V equals 1/3 pi R squared H. Let's indent, and let's talk about the H. Okay, so I know this H, and I know this is 30. Notice that's the adjacent side and the hypotenuse. So here's the angle of reference, draw my line through it. I have the opposite side here, I have the adjacent side here, and I have the hypotenuse here. Okay, just to be clear, this H is for height, not for hypotenuse. So when I'm looking at these two guys, if I want to find the height, and I can use this, I got adjacent over hypotenuse, which is cosine. So this is for height. So what I know is that the cosine of 18 equals the adjacent side, H, over the hypotenuse, which is 30. So height is 30 cosine 18. Okay? Now again, that's going to be irrational, and you can probably want to simplify it, or punch that into your calculator at the very end. Okay, let's talk about radius. So radius is, I can use the side that I know and one of the sides I don't know. That would be opposite over hypotenuse, which is sine. So the sine of 18, same reference angle, opposite over hypotenuse, is equal to the radius over 30. So that means the radius is equal to 30 times the sine of 18. If I'm solving for R, multiply both sides by 30. So there's my hypotenuse, there's my radius. Okay, now I can plug it all in. So V equals 1/3 times pi times R squared, which would be 30 sine 18 squared. And then I'm going to multiply that by 30 times the cosine of 18. Okay, so lots of trig going on there. Let's do it a piece at a time. Now you could type this all in your calculator. Oh, shoot. You can type this all on your calculator in one shot, and it would work, assuming you type it right. So just be careful here. So let's start with sine 18. So sine of 18 degrees. Multiply that by 30. And then I'm going to square that. So I've got this piece right here. Okay, that is 85.94-ish. Okay, now I'm going to take that and I'm going to multiply that answer by 30 times the cosine of 18. That's this piece. Okay, now I have all of this together. Now we need to multiply it by pi and by a third. Okay, so the volume is equal to 2,567.81 cubic meters. Now I would, again, double check that. Okay, so maybe this time we type it in all at once and see if we got the same thing. So let's do 1/3 times pi times 30 sine 18 squared times 30 cos 18. Cool. So yeah, I would, check multiple times to make sure that you didn't make any mistakes there, or just do it a piece at a time. Okay, so let's take a look at what else we got here. Notice special right triangles, right? 45, 45, 90. So, if this is 10, and this is 45, and this is 45, the ratio here in the 45, 45, 90 is if this is x and this is x, this is root 2 times x. So what we need to do is we need to divide by root 2. So this would be 10 over root 2, or 10 root 2 over 2, or 5 root 2 when we rationalize. Okay, so that's the radius and the height for this, because it's an isosceles triangle. So I'm not going to do the whole thing, but that should help you with that one. Okay, we're going to have another trig idea here. So, if you want to find this one, again, that's going to be like opposite over adjacent to this angle, so that you're going to use tangent there. And then this one, you're going to have to use Pythagorean theorem. So 30 is this diagonal, and then we know that the radius is half of 36, so that's 18. Okay, so for this one, you need to find the height. So 18 squared plus height squared equals 30 squared. All right, solve for h, and that's going to give you your height, and you're going to use that for the rest of it. Okay, so don't forget about your right triangle facts, right? SOHCAHTOA and trig ratios, special right triangles, Pythagorean theorem, all that kind of stuff is still very relevant, and this trig stuff will keep coming back. It's going to be something that you're going to use quite a bit in future math classes, so that's a good thing to practice. All right, that should get you started. Finish this out. Make sure you show your steps, box your final answers, and make sure you check the answer key as well to make sure you're doing it the right way. Thanks.